All right, hello friends. So this is another quick review series. This is part 3 on fractions. So we're going to talk about more complicated operations. What does that mean? So we're going to discuss simplifying fractions before you multiply or divide. So situations that look like what you see here. And we're going to discuss adding and subtracting fractions with different denominators, i.e. how do you find an LCD? So something like this is what we're going to get into. So I designed this review series to help you review for initially a math placement exam like ALEKS, but you can use this as a quick review if you forgot this particular topic in your math class. So just FYI, I might say some stuff about ALEKS, and if that doesn't apply to you, you can ignore it. My fraction series has 3 videos in it. I strongly recommend that if you hate fractions, you watch the entire series. I find that most people hate fractions because they forgot them. And so just doing a little bit of work to rebuild that foundation can go a long way. Okay, so the first thing that we're going to do is we're just going to do a quick review to warm up for this lesson. So just to make sure that you're good on this material, I want you to pause the video here and just write down your answer to what you see and then hit play when you're ready. So we talked about in the previous videos that when you have an when you have a mixed number like we have here, we want to convert it into an improper fraction. And so the way that we do that is, so I take 3 times the denominator plus the numerator. And so that's going to be 16. So that's going to be my new numerator. So this expression here can turn into 16 over 5 minus 2 over 5. And so this will equal 14 over 5. So just depending on the books that you're working with or the math placement exam that you're working with, it can be really common to have to convert mixed numbers to improper fractions. So we will be practicing that throughout this video. For the next problem, so to divide, what you have to do is you multiply by the reciprocal, i.e. you flip the second fraction and then you just multiply straight across. You don't have to worry about a common denominator. So this just becomes 20 over 21. So for these next two, so once again, pause here for a second, just make sure you've got it and then hit play when you're ready. Math is not a spectator sport. You'll get more out of it if you pause. Okay, so for C here, so I know that 5 is over this invisible 1, so I can just multiply straight across. So this becomes 10 over 7. And then for this other one, so once again, I'm just going to multiply by the reciprocal, but I know that this 4 is over an invisible 1. So this will be 20 over 3. Okay, cool. So now let's talk about how do you simplify fractions before you actually multiply or divide. So why would you even want to do that? So here is a great example. So I have 44 over 70 times 35 over 66. Now, I don't know about you, I really don't want to multiply 44 times 35 if I don't have to. So the thing to notice here is that 44 and 66 definitely have a factor in common. What are they both divisible by? They are both divisible by 11. So before I multiply, if you have one thing on top and one thing on bottom that are divisible by the same thing, you can divide. And it doesn't matter where they are in relation to one another. So for instance, so what I'm saying is if this had been 44 over 66, so as long as one is on top and the other is on bottom, I still could have gone ahead and simplified like this. So the fact that these are on a diagonal doesn't matter. It could be this situation or this situation, okay? So I'll just get rid of that. And so what about 35 and 70? Well, actually, 70 is 35 times 2. So interestingly, I can actually divide the top and bottom here by 35. So let's go ahead then and just rewrite this set of fractions. So 44 divided by 11 is 4. 70 divided by 35 is 2. 35 divided by 35 is 1, and 66 divided by 11 is 6. Now, you might notice here, there's actually a lot of different routes that we can go. And so this is kind of the beauty of simplification. And this actually illustrates several points because maybe you looked at this and you only thought of 5 divides 35 and 70. So this doesn't have to be like a perfect process. What I'm saying is that there's more than one way to approach this. But so here's how I kind of fell out with everything. So here's what I see now. 4 and 6, these could be simplified, or I could take 4 divided by 2. Either route is totally fine. So to me, what would be easier is if I take 4 divided by 2. What is 4 divided by 2? Well, it's just 2. So I could rewrite this as just 2 times 1/6. And so if I multiply those together, I get 2/6, and that will simplify to 1/3. Now, what if I was here and I just multiplied straight across? So let's just go a slightly different route just so you can kind of see what I'm getting at here. So what if I have 4 times 1 is 4 and 2 times 6 is 12? What does 4/12 simplify to? Still 1/3. So as you can see, I've now gone 2 different routes and ultimately I got to the same answer. So with simplifying, there's a little bit of an art to it in some ways. You might not go the most efficient way, but it doesn't matter if you're going the most efficient way. You'll still get to the same answer, right? And there's still different ways on how I could have approached this one. And in any way, as long as you get to 1/3, you approached it in the right way. Now, with division, there's one thing that I want to say. You need to flip the second fraction before you simplify. So what I mean is if I have this situation here, 66 over 70 divided by 33 over 49. So you can't simplify yet. To start this, the first thing that you need to do is you need to flip that second fraction. So I'm going to rewrite this as 49 now over 33. And now you can simplify however you see fit. So once again, I would encourage you to perhaps pause here and just simplify where you see that you can simplify, and then hit play, and let's see if we all arrive on the same things. Okay, so what I notice is that with 66 and 33, both of those can be divided by 33. So I'm going to divide those by 33, and then I'm going to divide 49 and 70 both by 7. So again, if these weren't the numbers that you saw, that's okay. As long as you get to the same final answer, it's all good. Okay, so I'm going to rewrite this now. So 66 divided by 33 is 2. 70 divided by 7 is 10. 49 divided by 7 is 7. And 33 divided by 33 is 1. So here's what I'm left with. And now I can multiply this straight across. So if I multiply this straight across, so let's see, I get 14 over 10. And that can be simplified. So I can divide, I'll just make this nice and clear. So I can divide the top and bottom here by 2, so that I'm left with 7 over 5. And so once again, so there's multiple ways on how you could have arrived at 7 over 5. Perhaps when you saw 2/10, you said, oh, I need to simplify this as 1/5. It doesn't matter. It's all good as long as you simplify to the right final answer. Doing this type of simplification definitely makes it easier to approach these problems, and then the rest of it just kind of falls out however. So now I think that you should practice this a little bit on your own. So I'm a really big fan of saying, math is not a spectator sport. So I strongly recommend that you just pause here and try these on your own, just to make sure that you're getting it, and then hit play when you are ready. Okay, so I noticed that 14 and 28 can both be divided by 7. And 15 and 25 can both be divided by 5. So I'm just going to rewrite this. So 14 divided by 7 is 2, 25 divided by 5 is 5, 15 divided by 5 is 3, and 28 divided by 7 is 4. And so now I can multiply these across to get 6 over 20. But I notice that I can simplify this farther. So this becomes 3 over 10. And so that would be the final answer. And once again, you might have seen a slightly different route to go. So now that I'm looking at this again, I could have actually divided 14 and 28. I could have divided both of these by 14. But, there's always that nature of just whatever kind of pops into your head first. So it's all good. Okay, so let's try B. So I'm going to rewrite this as 15 over 18 times 24 over 20, because I want to flip that second fraction first. And now the things that jump out to me are, so with 15 and 20, those are both divisible by 5. And between 24 and 18, both of those are divisible by 6. So I'm just going to start there. So this will turn into 3 over 3 times 4 over 4. And so really that's 12 over 12. So ironically, believe it or not, this whole thing just equals 1. And by the way, you can get a free PDF to write notes on at my website, divideandconquermath.com. You could just go to the review section to find a PDF. You're more likely to remember this material if you take notes, and I've got all the problems and everything set up in a really nice manner, all for free at divideandconquermath.com. Okay, so up next I have 2 more problems. So I want you to try these. And just as a reminder, so with D here, so the preferred manner is that we convert mixed numbers into improper fractions before we do anything else. So give these a try and then hit play. So remember that this 14 is technically over an invisible 1. So I'm going to divide the 21 and the 14 both by 7 so that this turns into, and so let's see, I can just put this 14 over a 1. If that bothers you, you could always just put that 1 as a placeholder. Some people like having the placeholder there just for symmetry or whatever. So this becomes 2 over 1 times 2 over 3, and so then this will equal 4 over 3. Okay. So for D here, so I take 2 times 6, so 2 times the denominator plus the numerator. So that's 13. That'll be the top part of that fraction. And then I do the same thing here. So 4 times 2 plus 1, so that's going to equal 9. So this whole thing then is going to be 13 over 6 divided by 9 over 2. So I can rewrite this then as 13 over 6 times 2 over 9. So in this case, there's not a lot of simplification, but I can go ahead and divide the 6 and the 2 both by 2 to rewrite this as 13 over 3 times 1 over 9. And so this will equal 13 over 27 when all is said and done. Okay. So now we're going to pivot to talk about adding and subtracting fractions with different denominators. So this actually is not like an easy skill. It's very common for people to forget how this works. So I want to break this into a few pieces just to kind of ease you into the ideas behind this. So where we're actually going to start is we're going to start with whole numbers plus or minus fractions. This contains kind of part of the philosophy for different denominators, but it's just kind of in a, I guess, easier to swallow flavor. So we'll start with 4 plus 2/3. Now, you might be saying, oh, that's just 4 and 2/3. Okay, so sure. Look, the point of this is to get you used to working with denominators. So what I want to do is I want to make this into an improper fraction. So I want to show you another way to think about this, because if we talk about it in this case, you'll see how it applies in the next case. So, be patient, grasshopper. So 4 plus 2/3. So I like starting with whole numbers and fractions because it makes it really easy to figure out what denominator do you need. So we're kind of just getting used to that, like what denominator are we shooting for? So when you have a whole number and a fraction, in general, the denominator of that fraction is the denominator that you want the whole thing to have. So we want to have an LCD of 3. And so the philosophy behind the LCD is, so I'm first going to recognize this as 4 over 1. So this 4 here can turn into 4 over 1. So the idea here is I want to take this and convert it into a fraction that has the desired LCD. So again, we're appreciating the philosophy here. You'll see where this is going in a few minutes. So this is the denominator that I want to have. So if that's the denominator that I want to have or get to, I need to multiply this 1 here by 3. And whatever you do to the bottom, you also do to the top. So keep everything balanced. And so now I've got 4 over 1 times 3 over 3. Now also just appreciate, what is 3 over 3? 3 over 3 is just 1, right? So this does not change the value of 4. It literally just converts it into an equivalent fraction. So it's kind of a fun trick. So, okay, so now what I'm going to do is I'm just going to multiply these together. 4 times 3 is 12. 1 times 3 is 3. So what is 12 over 3? 12 over 3 definitely equals 4. But now this will allow us to finish this operation. So now I'm going to rewrite this as 12 over 3 plus 2 over 3. And this equals 14 over 3. So I really want to just get us into that spirit of what LCD are we shooting for and how do we get to that, because it will help us in a minute. So I want you to try the same thing here just to kind of ease you into this. Pause the video here, give these two a try, hit play when you're ready. Okay, so in this case, the LCD that I want is going to be 7. So what I'm going to do is I'm going to take this 5 over 1. So I want it to have a denominator of 7. So I need to multiply this 1 by 7, and whatever I do to the bottom, I have to do to the top. So here's kind of the structure of how I'm going to convert this 5 into a fraction, equivalent fraction over 7. So now this whole thing, this 5 is going to turn into 35 over 7 minus 2 over 7. And so now, since I have the same denominator, right, so now I can just go ahead and finish the subtraction. So 35 minus 2 is 33. So this is 33 over 7. Okay, so let's do this one more time. So for B here, so the LCD that I want in this case is going to be 4. So this 6 needs to be rewritten as a fraction over 4. So I want to multiply the bottom by 4. Whatever I do to the bottom, I do to the top. So here's what I need to do. So now I can rewrite this whole expression as 24 over 4 plus 3 over 4, and that will equal 27 over 4. Okay, so this is a little bit of a preview of now where we're going. So now we want to talk about finding common denominators. So this is, again, another skill. So we have kind of a goal with this. We want to find the least common denominator to keep numbers manageable. I will explain that more in a second. We also want to find the largest numbers that divide into both denominators. So for right now, I just want to practice on finding common denominators, because once you understand this skill, then it becomes a lot easier to apply it to adding and subtracting fractions. So here's what I want to do. I want to take 1 over 6 and 1 over 10, and I want to find what is that LCD between them. Okay, so the easiest way to do this is you want to find the largest number that divides into 6 and 10, so the two denominators. So in that case, that would be, so the answer to that would be 2, right? Okay, so now what we're going to do is we're going to rewrite 6 and 10 as products of that number. So what I mean is, so I have 6 and I have 10. I want to be strategic. So each of these were divisible by 2. So 6 can be rewritten as 2 times 3, and 10 can be rewritten as 2 times 5. Okay, so what is the LCD? The LCD is what is that one number that evenly divides into both of those times what numbers do not go into both. So this is an overlapping number in the LCD and does not need to be written twice. So this is the one that overlaps. So it is that. And then these other numbers. So this will be 2 times 3 times 5. So my LCD will be 30 in this case. And for right now, this is all I want to do. I just want to figure out what is the LCD and get you guys used to that. Okay, so sometimes I have the question of why can't I just multiply the two numbers together? So 6 times 10 would technically get you a denominator. It would not get you the least common denominator. And the thing is, just multiplying the two denominators together can often get pretty messy. So notice 30 is smaller than taking 6 times 10. And so 6 times 10 I know is an easy calculation to make, but this creates an excellent segue into the next problem. So 14 times 21, sometimes that can be harder for people to do in their head. And so you want to try to make this, like, put in a little bit more effort for this to make this a smaller, more manageable number. So let's walk through this one together, okay? So I've got 14 and 21. So I want to rewrite both of these. So what's the largest number that divides into both 14 and 21? It would be 7 for both, right? Okay. Now, what I want to do is I want to write 14 as a product of 7 times whatever we need. So 14 is 7 times 2. So this one's straightforward. And what is 21? 21, pen's not working, sorry. 14 times 2. And 21 is 7 times 3. So my LCD then is going to be this number that they have in common, and then these other numbers that they don't have in common. So that's going to be times 2 times 3. And so that will be 42. So that's going to be my LCD for right now. Okay, so let's keep going with this. So I'll do this next one. So I've got 24 and 36. So now you might want to actually pause the video here and think about this and see if you can do this on your own. So 24 and 36, what's the largest number that divides into them? See if you can just finish this. Okay, so the largest number that divides into 24 and 36. So I actually like this because there's actually several numbers that may have come to mind. So the largest possible number for each is actually 12. Now, if you didn't choose 12, just hold that thought and we'll talk about it in a second, okay? So 24 is 12 times 2 and 36 is 12 times 3. So the LCD in this case, so again, it's what do they have in common, that 12, and then the numbers that they don't have in common. So times 2 times 3. And so that will equal 72. Okay, so there is that question then of what if you don't divide by the largest possible number? So what if you found, say, like 6, maybe 6 popped out at you? Well, if that happens, you'll just end up having to simplify in the end, and you'll just end up not getting the LCD. It's not the end of the world. So if I were to just redo this, so I've got 24 and 36. So let's say for both of these, I thought that 6 was the largest number that goes into both. So what I would have is, so this is 6 times 4 and this is 6 times 6. So what I would have then for my LCD is I would write, so here's the 6 that they share in common. So we've got that 6, and then here are these other unique numbers. So that's 4 times 6. So that will come out to 144. It's not ideal, but you can work with it. So you might notice though that 4 and 6, these have a factor of 2 in common. So that's just another thing to kind of watch out for. So if I'd noticed that, 4 and 6 have 2 in common, then I could have re-chosen how to do this problem, if that makes sense. And notice that this is still smaller than, so a lot of times what I see people do is they just take 24 times 36. So 24 times 36 is 864. So I'm not saying that this is the end of the world, but it is a very big number, and the larger the numbers get, the more likely you are to make a mistake. So I really think it's in your best interest to try to at least find the LCD, because it just keeps the numbers more manageable. This is like a really common thing that I see students do. Okay, so I've got one more here for you. So once again, why don't you pause here, find the LCD, and then we're going to move on with this skill. Okay, so let's see. What divides into both 50 and 35? So the first number that comes to mind for me is 5. So 50 is 5 times 10, 35 is 5 times 7, so I feel good about that. So my LCD is what number do they have in common? So that would be that 5. And then what don't they have in common? So that would be that 10 and that 7. So that 10 and that 7. And so this will equal 350. Okay, cool. So first things first is we've got to know how to find the LCD. So now let's talk about how do we apply that idea to fractions with different denominators. So let's start with 1/2 plus 1/3, just so we can kind of appreciate the process here. So 1/2 and 1/3, since these are two prime numbers, we can just multiply these two things together to get the LCD. So in this case, my LCD will just be 6. Okay, but let's appreciate what is 6. 6 is 2 times 3, right? That's literally taking this denominator times that one. So buried within this actually is the work that, or the path to move forward. So let's take each fraction separately now. So what I want to do is I can't add these together with the current denominators. They have to have a common denominator for me to add them. We talked about that in the previous video. So what I need to do is I need to rewrite 1/2 as an equivalent fraction with the denominator of 6. So The cool thing now about writing the LCD out like this actually is that this gives you a roadmap of how to do that. So what do I need to multiply 2 by to get to 6? I need to multiply it by 3. And you can see that in here, right? So 6 is 2 times 3. So this obviously already has a 2 in it. So we need to multiply by 3. And whatever I do to the bottom, I have to do to the top. So this will become 3 over 6. And intuitively, I know that 3/6 does actually simplify to 1/2. So I know that this is right. If I do the same thing for 1/3, so what do I multiply 3 by to get to 6? I need to multiply by 2. So whatever I do to the bottom, I do to the top. So this becomes 2/6. So now these are the two fractions that I need to add. So 3/6 plus 2/6, these I can add, right? This is all good. And so this just becomes 5/6, and then that's just like what we did in the previous video. Okay, so this is kind of the nice, simple version. Let's do a slightly harder version just to kind of see how this works. So now I've got 5/12 plus 3/20. So in this case, now I've got to actually do some work to find the LCD. So I've got 12, I've got 20. What number would go into both? The largest number that divides into both is 4. So 12 can be written as 4 times 3. 20 can be written as 4 times 5. So my LCD is going to be 4 times 3 times 5. Okay, and if I multiply those together, I will get 60 as my LCD. Okay, so having this roadmap is going to be very helpful. Having all this other work is going to be really helpful. So let me show you why. So now I need to rewrite 5/12, but I need it to have that LCD of 60. So how do you make 12? 12 is 4 times 3. And what I need my LCD to be is 4 times 3 times 5. So if you ever say, what do I multiply 12 by to get to 60? If you're saying you don't know, you do know. It's actually buried in here, right? We already know that 12 was 4 times 3. It's 4 times 3. So what is this missing? It's missing that, boop, times 5. So what do I need to multiply this fraction by? I need to multiply the bottom and the top, both by 5. So 5 times 5 is 25, and 12 times 5 will be 60. So we can do that again with 3 over 20. Okay, so 20 is 4 times 5, right? My LCD is 4 times 3 times 5. So I can see what is, I've got 4 times 5. This is what I want. So what do I need to multiply 20 by? I need to multiply 20 by 3. 20 times 3 will get me to the LCD of 60. So whatever I do to the bottom, I have to do to the top. So this becomes 9 over 60. And so now I've got 25 over 60 plus 9 over 60. And so that will equal 34 over 60. So can I simplify this farther now? Yes, I can now divide the top and bottom by 2 so that this whole thing simplifies to 17 over 30. So that would be the final answer. Now, this is actually a great problem to demonstrate, can you simplify before you add or subtract? So remember, with multiplication and division, we were able to simplify before. So is there anything that I could have done at this point to simplify this to go straight to 17 over 30? So this is one of the differences between multiplying and dividing versus adding and subtracting. So you cannot simplify beforehand. So just to show you what I mean, so what if I looked at this and I'm trying to add and I go, oh, I can divide these by 2 and I can divide these by 3. So what would this become? This would become, let's see, this would become 1 over 1 plus 1 over 2. And so that would be 2 over 2 plus 1 over 2, so that would equal 3 over 2. This is wrong. This is going to end up not being right. So if these two things were equivalent, so now let's use the proper process. So now, so I'm just going to say this is a big no. So now, what is my LCD? So my LCD in this case should be 12. So 3 and 4 have no common factors, so it's just going to be 12. So this is going to be my 2/3. I'm going to multiply by 4 over 4, so this is going to be 8 over 12. And my 3/4, so this is going to be 9 over 12. So what is this? This is 8 over 12 plus 9 over 12, so this equals 17 over 12. So 17 over 12 is not equivalent to 3/2. So you cannot simplify before you add or subtract. So you cannot simplify before you find your LCD, you finish your adding and subtracting, and then you simplify at the very end. So I know sometimes this is confusing, but this is something that's super important to keep straight. Okay, so if you are finding this content helpful, I would love it if you'd hit that like button or that subscribe button. And so what we're going to do now is we're going to do 2 more examples. So I have 5/12 minus 3/16. So just to check how you're understanding this, why don't you try this from start to finish and hit play when you're ready. The worst thing that happens is you get it wrong and then you'll learn something. Okay, so first I've got to find my LCD. So I've got 12 and 16. So what's the largest number that divides into both? Well, that would be 4. So 12 is 4 times 3, 16 is 4 times 4. So my LCD is this 4 that they have in common, right? They have 1 4 in common, so it's 4. And then these other numbers that they don't have in common. So this will be 4 times 4 times 3. And 4 times 4 times 3 is 48. Okay, so now I want to rewrite 5/12 with the LCD of 48. So I know that 12 is 4 times 3. I know that I need my LCD to be 4 times 4 times 3. So I need to multiply 12 by 4 to get 48. So let's see, I'm going to multiply the top and bottom by 4. This will become 20 over 48. And then for 3/16, so I know 16 is 4 times 4. The LCD I want is 4 times 4 times 3. So what do I multiply 16 by to get 48? I need to multiply it by 3. So I'm going to take 3 over 3. So this will become 9 over 48. So now I'm going to rewrite this as 20 over 48 minus 9 over 48. And if I finish this, I get 11 over 48. Okay, so hopefully if you made a mistake, you know where you went wrong. So what we're going to do is we're going to do one more in this video, but I do have a lot more practice problems in the practice problem video. So let's try one more like this, and then that will be good. Okay, so 24 and 16. So let's see. The largest number that divides into both is 8. So 24 will be 8 times 3. 16 will be 8 times 2. So my LCD will be 8 times 3 times 2. So once again, that equals 48. So 7 over 24, what do I multiply 24 by to get to 28? I need to multiply the top and bottom by 2 over 2. So this will become 14 over 48. And then 5 over 16, I need to multiply 16 by 3. So I multiply this whole thing by 3 over 3, so this becomes 15 over 48. Okay, and so now I'm going to have 14 over 48 minus 15 over 48, so that's going to equal -1 over 48, and that's as good as that one will go. Okay, so you can't master math by watching a ton of YouTube videos. You do have to practice it. So I do a few problems, but each review video has a companion additional practice problem set. So this is a free PDF of more problems like what we just did in this video. They do come with an answer key, and then I also have a video showing you how to work any of those problems. So what I recommend now is that you try that to test yourself on how well you're understanding this topic and to help you master it. So it's all available for free. Just go to divideandconquermath.com and then just look for the review section, and you can find all sorts of good stuff. So as a reminder, my fraction series has 3 videos in it. So I have tried to kind of build up everything with fractions. Fractions are honestly pretty complicated. So if this was the first video that you watched, I highly recommend that you check out the other 2. And hopefully that will help you rebuild your fraction foundation and maybe make you hate fractions a little less if you are one of the people that hate fractions. And by the way, my review series has many other topics in it. So my review series is not just on fractions. So each topic includes a refresher video like what we have here, the practice problems, the answer key, and then the extra videos with the worked out solutions. So I've got everything that you need. It's all for free at divideandconquermath.com. Just check out the review section and you can find everything there for free. You can use it to help you review for a class or for a placement exam, whatever you need. I'd love to hear what you thought of this video, and otherwise, I will talk to you guys in another video, I hope. Bye!